Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners for the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy course that's going to prepare learners for the DEVASC 200-901 certification exam. In this video, we're going to be focusing again on Lab 1.3.3, and we're going to be doing a Python programming review, and we're looking at Part 3 of the lab. And so in this video, you're going to be learning about some of the additional Python data types, specifically integers, floats. We're going to be taking a look at Booleans, and we'll talk a little bit about strings again. And then you'll also learn about the built-in type function that can assist you with figuring out and confirming what data type you might be working with. Now, a quick note with Python. Python, it uses what's referred to as loose typing, and sometimes you'll hear the phrase duck typing, D-U-C-K, because if it walks like a duck or waddles like a duck and quacks like a duck, then it's probably a duck. And so this is one way that you can remember how Python is going to do the typing for its different data types, is that it's going to make its best guess effort to say, hey, I think that this is an integer, or this is a float, or this is a tuple, or this is a string, and that's what it's going to go with. And so we'll get into that a little bit more as we continue on in the tutorials here. So let's go ahead and cruise over to our virtual machine. Remember, you can do this using the Python Interactive Interpreter. You could use IDLE to get there, the Integrated Developer Learning Environment, or we can use our virtual machine. So here we are back where we left off. Let's clear our screen here, and let's get back into the Python Interactive Interpreter. Now, the first thing we're going to talk about is the type built-in function, right? And so that's the function right there. Now, what can we use this function for? Well, let's go ahead and see what it thinks this data type is. Now, we know that that's a string, but this is a great way to verify that Python sees the same thing that we see. And I'll show you an example of where this might be a little bit confusing. What if I was to say type and put in the number, the integer 98, or what appears to be the integer? Now remember, that's enclosed inside single quotes, so don't be fooled here. You might say, oh, well, it's 98, that's an integer, so it's going to say class int. However, it's inside those single quotes. Now, the same thing would be true if we enclosed it inside of double quotes. Remember, Python is going to look at that and say, well, I see quotes around that value. That is a string. It is not an integer. So if I said type 98, then we end up with an integer. And so the type function can come in handy in some of your programs where maybe you're trying to validate, is something an integer? Is something a string? Is it possibly a float? 3.14, I think it's 15 there for the value of pi. And you can see that that's a float. And so we also see here some of the differences in the data type. So integers are going to be whole numbers. 1, 2, 3, 4, 5, 88, 99, 98 is in the example that we have here. And then floats are going to contain a decimal point. Now, there are some cases where you may run into a float value that's going to be simply interpreted as an integer, depending on your usage, and we'll get into that a little bit later on. And we've seen that this is how we can confirm that we have a string. Let's talk about Booleans. Now, Booleans are simply one of two values. It's either true, and that's going to tell you that it's from the class bool, or it is false. Now, again, one of the things that learners will ask is, well, what if I was to say false with a lowercase f? Is that going to work? And the answer is no. We're going to get a name error. So remember, with the Boolean values, we need to make sure that it's a capital T and a capital F, capital T for true, capital F for false, or else Python's not going to know what we're doing there. It's going to come back and say, hey, name error, I don't know what true with a lowercase t or false with a lowercase f actually represents. So the spelling needs to be precise. It needs to be exactly true with a capital T or false with a capital F. And we'll look at some of the different Boolean operators here that we could use. So let's clear the screen. And again, that's Control L on a Mac. So what if I wanted to know, is 99 greater than 4? Again, obvious, but you can see that Python's going to tell me, hey, that's true. Now, what about 4 being greater than 99? Well, that's obviously going to be false. So we've got greater than, we've got less than, we also have equal to. So is 99 equal to, and it's two equal signs here, right? And we'll talk about variable names in a second when we do the assignment operator, which is a single equal sign. But when we're working with equal to, right, we're trying to check to see if two things are equal, we're going to use two equal signs. And what if I was to come back and say, is 99 equal to 99? Well, that obviously is going to be true. So this is also a point of confusion sometimes, is learners will typically want to say, oh, is 99 equal to 88? Well, you're going to get an error here, and you're going to get an error on a couple of different levels. The first is, this is the assignment operator that we use to assign a value to a variable name. And so when Python looks at this, it sees 99 as the variable name. However, that can't be the variable name, because variable names, while they can contain numerical digits, in other words, my 99 things, that is a legitimate and valid variable name. However, 99 or something that starts with a numerical digit is not, right? So it can contain numerical digits. However, it cannot begin with a numerical digit for a variable name. So Python looks at this and says, well, that's wrong. And then we're not actually testing equality here. We're trying to assign the value, the integer, this object, this data type, right? We're trying to assign the value of 88 to a variable 99, and that's not going to work. But if I was to say my 99 things and assign it the integer value of 99, that, on the other hand, is going to work. And so then I would just simply type in the name of the variable and hit enter here in the interactive interpreter. Remember, we're in the interactive interpreter here, and we're going to get the value that that variable contains. And you may also hear sometimes that the variable points to. All right, so let's take a look at some of the other Boolean operators, and we'll circle back to variable names in a second. We can also do not equal to. So 99 is not equal to 9. Is that true or is that false? Well, that's true. That's obviously true, right? And then we've got greater than or equal to and less than or equal to. So is 99 greater than or equal to 99? Well, greater than or equal to, that would be true. What about 999? That's going to be false. And then let's check, is 99 less than or, oops, sorry, I'm going to type over that, less than or equal to 99? Again, that's true because it's less than or equal to. And then let's do something where, oops, sorry, I wanted to do something where it's not equal to, where it's going to be false, right? So it's not less than or equal to. 99 is not less than or equal to 9. So those are your basic Boolean operators that you're going to see. And so now what we can do is let's talk about creating some variables here. So again, variable name can be a single letter, right? It can be any uppercase or lowercase. It can contain and start with any uppercase or lowercase letter. It can contain digits, and we could put the underscore character in there. Now, I'm a huge fan of what's called camel case, and that is we start with lowercase, and so I would say my, and then if I wanted to spell out 99 things, that's camel case, where each subsequent word begins with a capital letter. And so I like using camel case, but we could also do something like this. I could say my underscore 90 underscore 9 underscore things, and that would be a variable name as well. And we'll assign the value of 99 to that. So again, we want to use uppercase or lowercase letters. I prefer camel case. Use whatever you like best. And then, excuse me, and then you can have digits in the name, numerical digits. but they cannot begin with a numerical digit, and we can also have underscores in there as well. What about dashes? If I said, my 99 things, my 99 things, and we're going to assign 99, and you can see it says cannot assign to operator. So we want to avoid the dash, right? We want to avoid the dash there. So underscores would be the way to go. If you were looking to use dashes, you're going to want to use underscores. All right, so we've seen integers, we've seen floats, we've seen strings, we've seen Booleans. So now let's go ahead and take a look at how we might use these variable names with the different data types. So we could say X gets the value of 33. I don't have to have spaces around it. I personally prefer the spaces, but you don't need spaces when you're using the assignment operator. Now, what about strings, right? So I could say string 1, and we're going to assign it the value of Cisco. And then we'll say string 2, and we're going to assign it the value of networking. And again, I'm following along with the lab part 3 here. We'll say string 3, and we'll assign it the value of academy. Oops, academy. I think I spelled that correctly. There we go. Now, I'm going to show you this little value add here. If you wanted to see in the current namespace, right? Remember the previous video I said when you exit out, you lose everything that you were working with. And the same is true here. However, if I wanted to see what is in a specific namespace, I would simply issue the dir built-in function. And dir is going to show me all of the things that are defined in the namespace. And I want you to think of the namespace as just simply a sandbox that I'm working in here in this interactive interpreter session, right? And so that's what we refer to as a namespace. And you can see, here are some of the values that I have in the namespace. String 1, string 2, string 3, there's that lowercase x, my 99 things. And then we have sort of these special, and these are called dunder because of the double underscore. So double underscore, we shorten it to dunder. So you would say dunder built-ins, dunder doc, dunder loader, dunder name. And again, these are things we'll talk about later on in the course, but just know for now that those are always going to be there in that interactive interpreter session when you first fire it up. So again, dir allows me to see what's defined in my environment. So we can also do something like this. If I wanted to create a space, a string that is a space, and that's what I just did right there. So double quotes, space, double quotes, that gives me a space, right? So now let's combine string 1, string 2, and string 3 and see what happens here. Now, in the lab, they show you to do it like this. They say print and then string 1, and then we're going to use the concatenation symbol. Now, with mathematical operations, that means add, and you might think of it as adding string 1 to string 2, but not from a mathematical perspective, but simply from a sentence structure perspective here in what we're doing. So we're going to concatenate string 1 to string 2, and actually they want us to put the space character in here, or I should say the space variable in there. And so we'll have some space in between string 1, string 2, and string 3, and we use print, and you can see it prints Cisco Networking Academy. Now, what would happen if I was to do this? Remember, we're in the interactive interpreter. This is not in a file, so is that going to work? Absolutely. And you can see it gives us back the fact that, hey, that is a string. It encloses it in single quotes. So again, the print built-in function can be used in the interactive interpreter. Doesn't have to be, but you can use it. However, in a file, we would need to put that in there as we saw previously, because this right here in a file is not going to produce the result that we're looking for. All right, so now that we've got that sorted out, there's also another way that we can do this, right? I could say string 1, without using the space, I'll use a comma, string 2, string 3. And that is also going to print it out, and it's going to give it to us in a tuple format, but you can see that it still prints it out with some spaces in there. And here is where we want to use string 1, string 2, and string 3 inside of the print function. So again, I wanted to show you what would happen if we ran it on the command line. It kind of looks at it or gives it back to us in a different format. But if we do it like that, we get Cisco Networking Academy. So here, it gave it to us as a tuple with 3 values. And we haven't talked about tuples yet. We will shortly. But you can see here's where we would want to use the print function to print that information out. And the comma gives us a space. And again, if I was to say string 1, excuse me, if I was to say string 1 and then do the concatenation character with the space, right? And you can see the spaces in there. That's what the comma is giving us here, right? So that's another way that we can print things out. Now remember, I said X is, and I put some value, 8675309, right? So if I type X, we get that value. Now remember, what data type is X? Well, X is an integer, right? And if we were to look at string 1, string 2, and string 3, and I'll just do string 1 here, you can see that that is a string. So what happens when we try to concatenate a string and an integer, right? Or 2 different data types. So let's go ahead and use the print function, and we would say we would say the value of the variable X is, and we're going to go ahead and that's our string, and I'm going to concatenate the variable X, right? You'll notice it's not inside the double quotes, so Python is going to say, oh, well, he must want to use the variable X. We've seen that the variable X is actually an integer, and we're trying to concatenate that with a string. And this is where we're going to get an error message telling us, hey, you can only concatenate strings to strings. You can't concatenate an integer to a string. And that kind of makes sense, right? So how can we fix this? Well, there's a couple of things that we can do here. We can pull this back up and we can convert the integer X to a string by putting it inside of the string function as an argument. And that's going to convert the integer X to a string, right? And so now we can do the concatenation here. And what if I was to do the following? What if I wasn't going to concatenate it? What if I put a comma there? Because now we're no longer concatenating with the plus sign. We're using the comma, which is a space separator, and that would also work. Now, you notice here, we've got 2 spaces right there. And the reason for that is, remember, what does the comma represent? The comma represents a space. So if I reran this, do I need the space here? I don't. So I can pull that space back. And then we get this similar output, right? We get the same output that we're looking for, except we don't have that extra space in there. So as you can see, this makes it very, very convenient from a programmer perspective that you've got multiple ways that you can approach these types of challenges when you're doing your programming. All right, so now let's go ahead and let's take a look at another way that we can do some formatting. Now, you remember when we talked about division, if I said num gets 22 divided by 7, the example that you see in the text, and I say num, you can see we get 3.142 and a whole bunch of characters after it, a whole bunch of digits after it. But let's check on that. What data type is num? Well, num is going to be a float, as you can see here, right? So we've got this float, and maybe when we're printing something, and I'm going to show you how you can use f strings here. If I said f, the value of the variable num is, and since we put the f at the beginning, I can use these curly braces here to enclose the variable name and keep it all inside of the string. And so by preceding that line with the f for the f string, we get a string that has the variable enclosed inside those double quotes, but with the curly braces, it tells Python, hey, pull in the value for the variable num. Okay, great, but what if I just want 3.14? What would that look like? Excuse me. Well, there's a couple of ways that we can approach this. Well, one of those, as shown in the lab, is I could say pi gets the value of, and we'll do the curly braces here, and we'll say :2f. Now, for now, just sort of except the fact that that is going to limit the value that we're going to print out for num, right? And you can see we're using that dot format, and that's going to print out or assign the value. Oops, sorry. And I actually didn't see I had two equal signs in there. There we go. I'm looking to my right to make sure we get the right thing. So that's going to have the value truncated to 2 characters. So what if I did this? What if I said 3F? Now what is pi? Well, we get 3 digits. So what if I said 4F? So you can kind of see how we can use the format method with a string. And that's what that dot format is afterward. We refer to that as a method because it's tied to the string class, and we're using it with strings. And that's what the double quotes surrounding that curly brace colon dot 4F. And so you can see some examples of how we might use this. So now we can go back to the F string, and I can say, oops, sorry, let's do a capital here. The value of the variable num is, and we can use the variable name we just created, pi. Sorry, and they want a period in there. The variable name we just created, pi. And so what's that going to look like? There you go. The value of the variable num is 3.1429 with a period at the end. So in fact, you know, they have that in there. I would almost prefer that it looked like that to be a little bit less confusing. And so again, we were using the format method. We'll talk about what methods are. They're inextricably linked to a specific data type or a class, in this case, the string. And so the format method is working with the string right here. And that allows us to truncate the output. And then we also saw F strings, right? So just different ways that you might be able to print some things out. Now, if I didn't want to use an F string here, how might I do that? I could use the print function, and I could say the value of the variable pi is, and we kill the string right there. I use the comma as the separator, and then we say pi, and what are we going to get there? There you go. So we kind of get the same thing, right? So it's just different ways that we can approach some of these programming challenges that we're going to run into, and how you might sort of integrate this into your approach. All right, well, this is part 3. What did we talk about? We talked about data types, we talked about variables, we looked at integers, floats, we worked strings back in there, we looked at some Booleans, we saw how we could use the format method for printing the output, and again, we're doing all of this in the Python Interactive Interpreter. All right, well, that wraps up Lab 1.3.3 Part 3. Again, thank you so much for watching. Hope you're enjoying the course. And as always, I hope to see you in the next video.